So, hello everybody. Thanks for sticking with me all the way to the end of the conference. So, this will be on target condition sampling. This was work mainly done by the first author, Xinyi Wang, but unfortunately she can't be here today, so I will present in her stead. So we're focusing on multilingual neural machine translation, and as we know, this is training models on multiple languages to translate, for example, into English, or maybe into multiple languages, but we'll talk about into English this time. And this is particularly useful for low-resource languages, such as Galician, as I show at the top here. And we would like to use this multilingual data to improve our accuracy on these languages. So there are multilingual paradigms that include multilingual training, where basically we just train one big model on multilingual data. There's also methods that train on high-resource languages and then tune towards low-resource languages. So this would be training on, say, for example, Spanish or Portuguese, which are similar to high-resource, and then fine-tuning to Galician. And also training on multilingual data and then fine-tuning towards a low-resource language. So basically, all these things, what they're doing is they're selecting some part of the multilingual data that we have, selecting it according to some strategy, and then applying it to get the best results on a low-resource language. So our proposal is basically to intelligently select data in a less heuristic way that allows you to do better in this scenario. And specifically, we are going to be talking about multi-parallel corpora. So multi-parallel corpora are corpora where we have the same sentence translated into multiple languages. And this is actually a surprisingly common occurrence. You might think this doesn't occur very often, but there are many, many organizations such as the European Parliament, TED, and Christianity, I guess, that translates the Bible into many different languages. So these multi-parallel corpora are common, and they're also very commonly available for even low-resource languages. So to formalize this a little bit, we will say we have S, or we have a target language T, which I'll assume is English for the entirety of this talk. And we have a source language S that we would like to translate, but in addition to this, we have other languages, S1 all the way up to Sn. And so what we want to model is the distribution of the source and target language, which is a joint probability distribution over X and Y. And if we had infinite amounts of data from this, we would be able to do very well at translation. So as we know, if we have lots of data, we can do well. But unfortunately, we don't have lots of data in the source language that we'd like to model. So what we're going to do instead is we're going to say, we have lots of data in another language, and we want to come up with a distribution that roughly looks like the data distribution in the language that we're interested in. And we'll call this rough approximation of the data distribution in the language that we're interested in Q, XY. So how do we construct this? Our method that we propose here is target condition sampling. And the idea is that we have the union of targets. As I said, I'll assume this is English, which means all the target sentences that we have in any multi-parallel corpora that we have available. We will then sample according to a distribution over the target sentences and get a target sentence here. We will look up all of the translations of this target sentence that we have in any of the languages in our multi-parallel corpus. And then based on this, we will condition on the target, hence the name of the method, and select one of these source sentences. So the overall framework is, I think, not too complicated. So then the question becomes, how do we choose these distributions? So for Q of Y over the target, basically what we'll do is we'll assume that the data from each language comes from the same domain. Obviously, this is an approximation that we used in this work, and you could relax this. But basically what this means is we uniformly sample from all target sentences Y, regardless of the language they have on the source, and we assume that this is matching our distribution over Y. Then our selection of the source sentence given the target is a little bit more complicated. So basically what this is doing is it's measuring how likely X is in language S. And this is non-trivial. So what we do here is basically we approximate it using a heuristic similarity measure, similarity of X to S. And so what this allows us to do is this allows us to devise a few heuristics that can tell us whether a particular source sentence is more likely to help with respect to translating the actual language that we're interested in. So we have two dimensions with which we estimated this similarity function. The first is what heuristic we use to estimate it, and the second is the granularity with which we estimate it. So the two heuristics we use are overlap, word overlap, and specifically, sorry, not word overlap, but specifically is the variety of overlap that we use. We use character n-gram overlap between S in the language and each sentence. And the reason why we use character n-grams here is because we would like to take into account that some languages are very similar, but they, in spelling, but they have a few differences. So we use character n-grams instead of words. The other one is language model. So we use a language model over the language S to score each sentence or to score all sentences in each language. And based on this, we decide which data we should be selecting. So as I say, on the we do this both on the sentence level and on the language level. So the idea being that we can either score the particular source sentence that we're trying to select, or we can score the entire language itself. In terms of algorithms for data selection, we first sample Y based on QY, and then we sample X based on Q of X given Y. And we can do this sampling in two ways. The first way is to, for stochastic sampling, we basically dynamically sample the source sentence for every mini batch, so we might pick a different source sentence every time. Then the other way is to do it deterministically. So we're not actually sampling, we're just picking the sentence with the highest score. So we did an experiment with respect to this model. We have a 58 language to English TED dataset that we've used for a number of experiments. And we have 4 test languages, Azerbaijani, Belarusian, Galician, and Slovak. And our baselines are basically pairing each low resource language with one related high resource language. Our second baseline is training on all 59 languages, so this is basically using all the data that we have across all languages, regardless of the similarity. And also, we also copied data from the English side to the source side, as was done in Curry et al. So first, comparing with baselines, we compare with the all method, the copied method, and our TCS method. Here we're showing the relative difference from the bilingual data selection method. So increase means it's better than bilingual, decrease means it's worse than bilingual, where we select a single language based on the heuristic. So first, we can see that training with all languages is kind of a wash. In the case of some languages, it's about the same. In the case of Belarusian, it's a bit better to train on all languages. In the case of Galician, it's a bit worse to train on all languages. Then with respect to copying English data, we see that this actually does significantly worse in the case of Azerbaijani and Belarusian, and it does a little bit better in the case of Slovak. The reason why it did a little bit better in the case of Slovak was because our bilingual language is Czech, which doesn't have as much monolingual data as we had in English in this setting. And then finally, if we look at the target condition sampling using the stochastic method, we can see that this gives consistent improvements in all settings. So despite the other ones kind of being inconsistent in the gains, the target condition sampling seems to do better. Then comparing the design space within this, we compared the deterministic method with the stochastic method. So basically the deterministic method, what it's doing is it's selecting the same sentence every single time. So there's less variety here, and we can see that the stochastic method tends to do better. Although sometimes it's only marginally better. So in the case of Slovak, actually deterministic sampling is not that bad. Also, we compared language model-based methods with vocab overlap-based methods, and interestingly, the vocab overlap-based methods seem to do better on average. I think this is notable because language modeling-based methods have been used for data selection for MT in the past, so this was kind of an interesting result. Additionally, we found that selecting data on the language level as opposed to the sentence level gave more robust estimates. So on the sentence level, if you look only on the sentence level, you get kind of overlap by chance as opposed to overlap by the fact that the languages are actually better. So doing it on the full language level was more robust. So our conclusion is basically this is a very simple method for better selection of multilingual data in the case where we have multi-parallel corpora, and it brings significant improvements with little training overhead. We have our data here, and I think interesting future work is to expand this beyond just multi-parallel corpora to fully selecting data over all kinds of different languages. So thank you very much.